Hey, I'm Matt, CEO and co-founder of Mawson Rovers. Today I'm going to give you an update on our R1 prototype lunar rover. So we've got a bit of hardware here to show off. You might remember from last time we had this motor housing part that we talked through. Well, today we're gonna look through this completed motor housing and planetary gearing system. I'm going to take this apart and see how it works inside. Then we've got a completed wheel assembly here. So the motor housing sits in there. We'll talk through how this turns and how the motor and the encoder and the drive controller work to drive the wheel in here. Then we'll have a talk about the machining process and how these blocks of aluminium get turned into pieces like this bracket here. And then at the back there, we've got a couple of the first pieces of our steering and suspension system. So we'll save those for a later episode. So let's start by looking at this completed motor unit, drive unit that fits inside the wheel. So when you see this wheel here, you can see on the inside there, this is the kind of assembly here that sits inside this wheel. And so at the back of this, you can see the shaft here that connects to the motor. There's a piece missing in here. The motor shaft actually takes this static magnet, sits on the outside, and then the motor there turns the magnet, which then turns the shaft, which then, as you can see, if I turn it around carefully, it's driving that around. So this motor and gearing system is a 6-to-1 reduction, which means that if I turn this shaft around 6 times, the output will move around once. But what it really gives us as a benefit is that I can turn this motor really fast and not very strongly, but it gives us 6 times the torque on the output here. And together with this, this is called a brushless DC motor, and the precision encoder we'll have here, it allows us to really drive this motor very precisely and control exactly where the wheel position is. And so when you're driving on difficult, uncertain terrain, like we will be on the moon, it gives us a lot of control over where the wheels are, exactly how they move, and because we have independent control of every wheel, we can get ourselves out of potentially sticky situations with difficult soil. So then if we take this apart and take the cover off here, you'll see inside, oops, it's just slipped out there. Tricky to get it out. You can see inside we have the motor shaft connects through to this planetary system here, planetary gearing system. So I'll just slot that, try and line that back up and get it back in again. It's got to be very precisely lined up. There we go. So now, when I turn the shaft here, you should be able to see how this gearing system actually works. So it's converting that rotation at the back into rotation of a small gear in the middle, which rotates those 3 circular gears in there, which have bearings inside them, connected to this housing here, which then is sat inside what's called an internal gear. So it's that gear with the teeth on the inside up there. So now if I take the shaft out of here, you can kind of see how it has these teeth. I think it has just 12 teeth, and that fits into the middle there, where it connects with those 3 planetary or planet gears, as they're called. So that's what allows us to really have a 6-to-1 reduction in such a compact space, this planetary gearing system, which you'll see commonly in robots and other high precision geared vehicles, because they need this kind of increase in torque and decrease in speed from a high speed motor in a relatively small package. So those gears are only, this wide. The motor sits here. And yeah, so we can get that kind of performance out of a small space. Now, if we go onwards to look at the wheel assembly, you can see that the wheel's mounted on the outside of this piece that was connected to those planets. And as I turn the shaft at the back here, you'll see again that the wheel rotates 1/6 as fast as I'm rotating this shaft at the back there, but with quite a bit more force. And so inside this bracket at the back, we're going to have an encoder mounted here and an encoder ring. So an optical encoder looks at a disc with lines marked on it, and it can use those lines to determine accurately the position, and not just the speed that the wheel's rotating, but also the exact position of it. And that information is fed back into a controller. And so we'll have the controller as actually be a very small circuit board that mounts in here as well on these screws. And then we'll cover this up with a bit of a plastic cover at the back here. What hasn't been completed on this bracket yet is drilling the hole through here, and actually the kind of fixture unit here that connects this up to the steering system. So this wheel unit will have a steering column on top of it and another motor up here that allows it to pivot 360 degrees actually, because it'll have a slip ring design in it. And so yeah, pretty soon once the motor controllers are ready, we'll be able to rig this up and see it spinning around with the motor and be able to precisely control it as well. So that'll be an exciting step forward. And all of these pieces we're making all of them as we go. So you know, we have a 4 or 5, 6 pieces of each of these things ready so the whole rover will be ready as we complete each piece. Now, if we look at the bracket here, so this bracket that you see on the outside here, it comes out of a solid piece of aluminium here. It's actually 3-inch aluminium plate. That's the way it starts. And then for this piece, it's milled with a CNC mill. And you can see here it is after 1 or 2 operations on the mill. It's kind of taken out all this metal that was inside here. These holes have been tapped here. And then what happens after this is then we put it in a fixture and then mill out all the stuff on the other side so that eventually it will end up like this one. So you can see these shapes here look the same, like that. And then all this aluminium needs to come out as part of the machining process. So that's what will be next to make all these brackets and get them ready for connecting the next pieces of the rover. And so that's what we have for show and tell today. We have our new wheel, which is very exciting. Hopefully get that connected up to a motor soon so you can see it spinning around. And then we're starting to work on the next pieces of the rover. So this is a piece of the suspension system where the spring dynamic articulation support is there, and it also supports a motor internally for active suspension. And then this is the first piece we've made out of the steering system. So this is connecting the steering motor to the housing as well. So we should see some more pieces of this coming off the machines over the next few weeks, and then continue making progress on the R1 prototype lunar rover. That's it for today. Hope to see you again soon.